Hello, in this video I'll present a project I developed, a compiler for a domain-specific language designed to demonstrate geometric transformation in computer graphics. This language allows to define objects using vectors and apply transformations such translation, scaling, and rotation using matrix operations. We start by defining the object using three vectors. We set the color to 1, and define the points A, B, and C. These vectors represent the vertices of a triangle. Then, we group these vectors into a matrix called M, which represents our object. Now, I run the code and we can see the results. We can also see how the mathematics operations are performed. Here we have the three vectors A, B, and C, and the matrix M containing these vectors. Translations. We set the color to green and define a translation vector G, which shifts the object 4 units along the x-axis. This vector is replicated into a translation matrix T. Then we compute M1 equals M plus T. This applies the translation to the object, generating a new matrix M1, which represents the translated triangle. Scaling. Now we move to scaling. We define two vectors that form a scaling matrix, the vectors f and g. In this case, the values scale the object by a factor of 2. In other words, the object will double in size. Next, we store the vectors in the matrix E and perform the matrix between E and M, storing the result in M2. Rotation. Next, we define a rotation matrix using trigonometric values corresponding to an angle. These values represent cosine and sine components. After that, we store them in matrix R, which will be used to rotate the object. Now, we can make an animation with loop using the repeating tool. Inside the loop, I include a short pause to better observe the animation. During the rotation process, M is multiplied by R and the result is stored in M3. After that, M is updated with M3. This process repeats 24 times, creating a smooth rotation animation.